Good evening, everyone. Thank you for joining our online webinar. My name is Anna, and I work as a recruitment officer for Juvo just over 5 years now. In our talk today, we invited Sam Vroeperix, who will give you the insights about NX Workspace. Sam is a freelance software engineer, internet entrepreneur, and an expert when it comes to front-end technologies. This webinar is hosted by Juvo, and before we kick off, I would like to tell you a little bit more about our company. We are a professional services company specialized in data productivity improvement projects. And over the years, we have established ourselves as experts in application development based in Java and going from backend to frontend, full stack, web, process automation, and implementation of AI and machine learning technologies. Now, besides application development, we also specialize in business intelligence, data engineering, and data analysis. Now, we are also looking always for bright talents with Java backend, frontend, and full stack experience to join our team. So if you are currently looking for a new challenge, or if you are just curious about what we have to offer, I would highly recommend to take a look at our website or get in touch with me, and I would be happy to go over the possibilities. Now, we are big advocates when it comes to knowledge sharing, and that's why we host these kinds of webinars on a regular basis. This webinar will also be recorded and published afterwards on our YouTube channel. You can find the link of our channel in the chat box. And yeah, you can also find previous recorded talks about certain topics as well. Now, if you have any questions during the webinar, drop a line in the chat box and we will discuss them during our Q&A at the end. And we will also tell you a little bit more about our next webinar. Now, with that said, let's dive in our talk from today. Sam, the floor is yours.
Hello, good evening. Thank you for the introduction. And thank you for joining my session today on NX Workspaces. Tonight, we're going to explore some awesome features and superpowers that this framework provides. But first of all, a big thank you to Juvo and Nick, Dimitri, and Anne in particular for the opportunity and the organization of this event. So, as I said, the session is centered around the capabilities of NX Workspaces, which is a framework or a tool, whatever you want to call it. And we will start with an introduction to give you the high-level overview that you need to understand some more advanced concepts. One of those advanced concepts or in-depth concepts is caching. And caching, as you might know, is one of the most difficult areas in computing, but I promise that for today, for this session, we will keep it lightweight and specific to our current use case. Another concept is that of dependency graphs and how they can optimize our development and software release processes. And in the third part, we're going to apply the theory and concepts into some basic practical examples. And if you want, you can just watch me explore the code base live and while I navigate through the project, or you can code along with me, whatever you prefer, but there's not really much to it. I will just show you some basic examples. The examples created and the commands that I will use will be shared afterwards via a public GitHub repository. And at the end, you will be able to ask questions, but can I kindly ask you to write down your questions till after the presentation? Our time is a bit limited, but I promise to answer your questions in the Q&A session afterwards, if I can. Before we take a deep dive, short, who am I? Well, obviously, my name is Sam, and I've been freelancing and playing with the web as a software engineer for almost 15 years now. My sole focus has always been on the development of the internet. So the only thing that I did in my professional career is basically web development. Besides that, I'm also the managing partner of Innovatus and one of the organizers of NGBE, which is the Belgian Angular Conference, and also one of the organizers of the Angular Belgian Meetup Group. I'm also a GDE, which is short for Google Developers Expert. And in that role, I am in support of the Angular and web communities worldwide. I have one son, Milo, who is almost 2.5 years old, and my girlfriend Zoe is expecting our second son in just a few weeks. So let's hope that he will not come early, like in just an hour or so. Let's hope that does not happen tonight. I also try to write about the technologies I use on a daily basis, so you can find some articles about Angular, progressive web apps, service workers, Scully on my blog. So if you're interested in that, please check it out. So as I said, I'm running a company called Innovatus together with Jurgen van den Moeren. We mainly work around initiatives in the community of Angular developers, like, for example, as I said, the Angular Belgium meetup group and the NGB conference. And since this year, we've also started taking on apprentices as well. And I've been coaching 2 interns over the past months, training them as new Angular developers. Through our initiatives over the years, we can say that we have trained thousands of engineers in Angular and also related technologies in and around Belgium. Of course, that would not have been possible with the help of some amazing people, of which you can see some in the picture there. We also deliver some expert consultancy in our field of the Angular ecosystem, but also the web in general to companies all over the world. So me and Yuri were both recognized by Google for our knowledge and expertise in web technologies. That's why we are mentioned on the Google website as experts in our domains. What does this mean? Well, this recognition gives us direct access to Google previews of new developments before they are made public. And that allows us to respond very swiftly and quickly to changes and prepare documentations for our clients and the communities that we support. So that was it for an introduction of me. Let's go back to the subject, NX workspaces. And let's start with a swift introduction and background on the framework. So NX is a framework developed by a company called Narwhal. And Narwhal is founded by 2 ex-Google employees who've been working as core developers of the Angular framework in the past. And since 2016, Narwhal has built up an amazing reputation in the web development ecosystem by contributing to open source a lot and making their NX framework available to the world. This has led to a lot of trust by developers and consultants worldwide who are now advocating for the usage of the framework in their projects. And because it's open source, a lot of contributors have been improving the software and extending it through the development of plugins for example, other frameworks like Vue and Svelte. Allowing contributors has made it a very robust and reliable framework, which is now covering many different and very particular use cases. In its essence, NX is a smart and extensible build framework. It enables us to architect, develop, test, build, and scale our applications. So it integrates with ease with modern web technologies and provides support for the most modern frameworks out of the box or through plugins, as I said, built by community members with the support of Narwhal. So supporting this wide range of web frameworks is mainly possible because NX is built on a technology agnostic core, meaning that it can be used to facilitate and support any technology that you want, if there are plugins available for it, or if you are willing to extend the framework yourself. And last, but definitely not least, NX is optimized for usage with monorepos or very large repositories. The added benefit of NX becomes more prominent the bigger your code base grows. So NX understands basically the relations between the most small or granular parts of your code base and optimizes its processes according to those relationships. For example, caching allows you to still have an acceptable speed while maintaining an enormous growth, and also by doing smart analysis of changes. For example, you only execute the bare minimum that you need to execute. More info on all those things coming up soon. As I mentioned before, NX comes with first-class support for many modern frameworks. Also, like I said, if not out of the box, other frameworks are probably supported by plugins by the community. or they are at least in development. The documentation of NX, it's provided in 3 flavors: for Angular, for React, and for Node.js. Those are the main supported base frameworks for now, and they enable other frameworks, like, for example, Nest.js, Express, which is built on Node, Gatsby, and Next.js, which is a React framework. And by default, newly generated apps and libraries come with unit testing support enabled by Jest and end-to-end testing support provided by Cypress. As you might know, ESLint is now the default tool for linting our TypeScript applications because of the recent deprecation of ESLint. And this comes out of the box with NX. But as you also might know, that's a little bit different from the Angular CLI, which is not providing a default linter anymore since the latest version. Storybook is also maintained as a default plugin and can be used for showcasing like shared components or features. And it can also be used to run integration tests using Cypress on a library or even a component level. And the good part is that all these default integrations are supported and upgraded automatically using migrations. So when NX is upgraded to, for example, a next or the latest version. So when some specific configuration of a supported plugin is refactored or updated, NX probably has you covered in most of the cases, and it will change all those configurations automatically. That is, of course, if you do not do very custom and exotic configurations, of course. So the main features and strengths of NX are built around optimizing the processes that allow us to reliably release our software into production. And making and keeping those processes optimal while our code base is growing can be achieved using several techniques. And those proven techniques are by definition not new, but there has been a big gap in the past combining them all in one framework or tool in our JavaScript development ecosystem. So NX does a great job combining several of these techniques, like, as I said, facilitating the monorepo style of development by providing the tools that know how projects and libraries are relating to each other. It also provides a consistent syntax for executing tasks like, for example, building or testing or serving our applications. And this across all different frameworks. So think React versus Angular versus Vue versus Svelte, even versus backend frameworks. And then we have smart techniques like dependency graphs that can be used to only execute specific tasks when they are needed. On the more low-level code level, we can restrict code usage by setting constraints between libraries and applications. And the last thing that we will discuss as a main feature is that we can cache our output and the file generation locally or even remotely on a server so that the whole team or even the whole IT department of your global worldwide company can benefit of this shared cache. Now, let's take a closer look on each of these topics. So NX advocates the methodology of monorepo style development. And to put it simply, a monorepo is just a single repository that holds the source code for multiple and if not all applications and libraries in your organization. So typically together with the source code, it contains the tools to manage that source code. And these tools are needed because the bigger the repository becomes, the more management and maintenance it will need. So, but why would you go to a monorepo style of development? They come, of course, with some major benefits, but they also impose some other big challenges. There, the power of NX comes into mind because it has you covered on all those challenges. So, first of all, sharing code between teams in a monorepo becomes easy. Code sharing keeps your code dry and promotes consistency. So for example, only defining UI components like, let's say, a button, to take the most simple example, If you only define that once, and you make your entire organization use that one button or one button definition, a button in all your applications over all your organization application will look the same. And if you support React and Angular, or even more frameworks on your applications, you could, for example, only share the CSS styles of those buttons. And you could even create a generic custom element or web component to support all those frameworks in one go. Another great example is the sharing of TypeScript interfaces between backend and frontend applications, which will allow for a clear and easily maintained contract while doing communication over HTTP. Then the consistent syntax in running commands increases the developer experience and the mobility of a developer. So even when applications of other teams in the same organization are developed using other technologies, one developer can still contribute or improve code of another team or a completely different other part of your organization with confidence, because the tools and commands that developer needs to use are very similar across all applications and libraries. So the tools play a very big role in verifying and testing the changes and additions that some developer has made to the code. And then another last benefit that I want to discuss, benefit of monorepos, is that sharing a single set of dependencies does not only improve the interoperability of shared code, but also enforces smaller parts of your code base to also be kept in shape. So frequently upgrading the dependencies and forces you to check against breaking changes even for the smallest parts of your monorepository. If you do that, you can potentially avoid a very big technical debt in the future. So those were benefits of monorepos. We also have, of course, challenges. By just putting all code in one repository is easy. But of course, we need to have sufficient or appropriate tooling to maintain it. If we don't, we have the risk of executing unnecessary commands, like, for example, running the build or testing all applications and libraries that were not even impacted by a small change, which could have happened in a completely different part of the repository. And this could create a very big overhead on, for example, automated processes like your continuous integration and deployment process. And another risk or challenge is that we can, well, mainly a risk in this case is that we can import or change wrong code because there are none or perhaps minimal boundaries defined on the different parts of your repository. To give you an example, we could have a library with code that was intended to be used in only one application. And the intention was not to share this piece of code as a shared service. So it gets imported by another team, but it doesn't work. It was not intended to work. So we need some way to block that. Another example is that a developer from another team goes into your code and changes the internals of a function, leaving behind some bugs or inconsistent code that does not match with the style guide. How does NX help us with those challenges? Well, in different ways. First of all, it can help you scale your repository by using, for example, consistent syntax in command naming. And then we can run those commands only if they're part of by the change affected dependency graph. And what that all means, we'll check out later. But in general, that will make us run less commands, and by adding caching, the command that needs to run faster. By tagging projects and applications, we can define our boundaries on a code level and control the allowed relations between the most small parts of our applications. And if you use, for example, GitHub, you can also use, for example, code owner files that can be used to set a restricted list of developers that can modify specific parts of your code. Then, by using schematics to generate our code, we will enable a consistency over all our libraries and applications And by using, for example, migrations and plugins, we can minimize the manual work that we need to do for example, moving or renaming libraries, generating new ones, and adding new capabilities, like, for example, creating a React application in our mainly dominant Angular monorepository. That's all possible with NX. Then, finally, NX understands your code and the relationships in between all the parts. So, and even if it does not, for some reason, understand the relations, you can manually instruct NX on some relations it cannot auto-discover. And this results in a very accurate overview of your architecture, and it allows you to quickly respond to potential problems, but also allows you to generate valuable documentation. Just a second. So with NX, it does not really matter whether you use React or Angular or Vue or Svelte or even Go or .NET or yeah, it doesn't really matter, because invoking a build for your React app is done using the same command as you would use for running a build for your Angular application. The only difference is that the arguments are different, and what gets executed under the hood is different. And how is this achieved? This is achieved using executors or builders, which is basically an alias, but in Angular, we typically use the term builders, and builders are defined on a project level in the workspace.json or angular.json file. So don't worry if all those references to files are still unclear to you. I will show that in the practical example. So builders are defined on each separate app or library. And the most common builders are, for example, build, test, lint, and serve. And these are typically also provisioned when you generate a new library or a new application if you use the schematics that are provided by NX or the Angular CLI. So the executors or builders, they allow us to use a consistent methodology for running similar actions on unrelated projects. So, for example, a developer that is used to running the build command for application 1, as I already said, for example, a React application, will be very confident that he can also run the same command, but for another application in Angular. It will run in a similar, and if not exactly the same way, with the same default conditions applied. And the developer does not need to care initially if the project was built in Angular or React. NX, so we talked about benefits for the developer, but NX also leverage this consistency in the naming of executors and builders, because it can run similar actions on a wide range of projects. So we can run a command in the terminal to run the tests that will run the tests on all applications available by just calling test. And NX will know that it needs to run that specific executor for that application, that specific executor for the other application. So it really provides a very consistent syntax to use. Let's take a look at a very short example. So what we see on the left, I hope you can read it. I think so, it's big enough. Is a very small part of the Angular or workspace.json file. And here we have two definitions of executors for the admin project, which is an application built using web components. We will take the first one. It's named build as an example, but just as builder is an alias for executor, architect is an alias for targets. And each executor defines the action to execute and the package that holds the action. So in this case, Narwhal has provided a web component package that exports the build command. And note that in many cases, the know-how package is just an extension or a wrapper around existing technologies, like, for example, the Angular CLI. And next, we also have a definition of the default options that are provided to the build executor, and also configuration options that allow us to override specific options, like, for example, enabling optimization in a production build. So invoking this specific builder can be done by providing first the name of the builder, then the name of the project, and an optional configuration reference like production, and specific overrides that can be specified on the command level as well. And that results in, for example, mx build admin using the configuration, the production configuration, but again, overriding the optimization flag. That's a bit stupid, but just as an example. So to be able to practice the monorepo style development, you need to know how different applications and libraries are relating to each other. And NX gives you the tools to programmatically and visually understand the dependencies in your code base by building dependency graphs. And for that, NX uses three main inputs to calculate the dependencies between projects. One of those inputs is generated by doing code analysis on all our TypeScript imports. So, for example, by analyzing the import of the process save HTML function of the util save HTML library into the feed news overview library, NX knows that this feature library depends on that other particular util library. If for some reason there is no import that explicitly results into a dependency between projects, we can always manually add an implicit dependency to the configuration of the project. Besides that, we can also define a global implicit dependency that should be taken into account whenever it contains a change. So, for example, when we would install a new dependency in our package.json or upgrade the version defined in there, we consider all libraries and apps to be affected with a change. And the configurations that you see here will result in the dependency graph that is shown on the screen now. So, just to understand, in many organizations, even the smallest one, a monorepository can quickly scale to tens or hundreds of different libraries and applications which are depending on each other. So even if your organization is of bigger proportions, like a multinational, for example, thousands of libraries is not an exception anymore. For example, I've been working on a project since April last year, and I think we are at around 250 or 300, between 250 and 300 libraries now. And we're working with around, let's say, 10 developers. So over a little bit more than a year, we created almost 300 libraries with 10 developers. And we're only at the start of our development process. So it will scale quickly. It scales with the amount of features that you build. Now, because of what I said before, the consistent syntax allows you to stay your, wait, I'm skipping something here. So if you want your teams to stay productive, you want to be confident that if somebody makes a change, it does not break other applications. So you want to be confident if you change one of those libraries, that you do not break an application somewhere else in the organization. But because of the consistent syntax in how we are executing commands and actions, you could rebuild, retest, relint, or even run your own custom target on all apps and libraries on every single commit to your repository. But running it all, effectively all of them, so on all your libraries and apps, will be costly and very time consuming. So NX gives you the tools to quickly get a list of which apps and libraries are affected by your change. As a result of that, as a side effect, it can also enable commands like the affected command that makes use of that dependency graph that holds the affected changes to only execute the tests and builds on the libraries that were truly affected by the change. For that, let's take a look at a small example. So what we see here is an example dependency graph of two applications, the API application and the CMS application. So the CMS application also has an end-to-end testing app. And this dependency is annotated by an implicit dependency, which is configured in the annex.json. And why is this needed? Because the testing apps typically don't have a direct TypeScript import to the applications. They test against a running version of your application. So therefore, the implicit dependency, which is annotated with the bolder arrow. But each app also imports code from a feature library. So API imports API feed users library and the CMS imports CMS feed users library. And each of those feature libraries also depend on a data access library that is specific to the feature. Both the feature libraries and both the data access libraries also depend on a shared type library that holds the TypeScript interface describing the properties of a user. So imagine that we make a change to the CMS data access users library. In this case, it would only make sense to rebuild and retest the libraries and apps that depend on this specific library. So in this case, the directed dependency graphs gives us immediately a very good overview of the impact of this change. And now running the affected commands for build, test, lint will only retest and relint the CMS data access users library, the CMS feed user libraries, run the test, lint and build for the CMS application, and also run the end-to-end tests for the CMS end-to-end testing application. Oh, that was a mouthful. But you can see it clearly from the dependency graph here. The red libraries and applications will be the ones that are retested. Well, the next concept, defining code boundaries. So by defining constraints on the projects, we can limit the import of certain libraries into other libraries and applications. And there are several reasons why this might be a good idea. So, for example, certain features might only be relevant to a specific application. So it's completely useless, also from a business perspective, to import them in other applications. But importing them in other applications could also not work as expected. So we should try to avoid that. And for that, we can use scopes, and we can define the relation between those scopes to limit imports. So in this example, we see again that same dependency graph of two applications making use of different libraries. We have the backend application API and a front-end application CMS. Now, importing a backend API feature, which is in our case clearly a Node.js library, into the front-end Angular CMS application does not make sense at all. Blocking that specific import can be done by annotating or tagging all apps and libraries with a scope. So the API apps and libraries get the scope API tag. The CMS apps and libraries get the scope CMS tag. And that one shared type library, which is containing the TypeScript interface that is basically used by all the libraries, gets the scope shared tag. And as we already saw before, the configuration of our projects is done in the annex.json file. So each project entry already exists in that file. So adding the tags for it is basically peanuts. But when you know the tags up front, you could also specify them directly as options when you are generating the library or the app. So let's, for example, take the API feed users project. Generating this library was done with the command that you see on the screen. And adding tags is basically as simple as that. The last step that we can do to limit those imports is configuring the linting process that will warn us or even completely block the wrong imports. So blocking means that the build will fail or the linting process will fail. So it will probably stop further execution of your CI/CD process. And for that, we can use an ESLint rule, which is also developed by Narwhal, which will enforce the module boundaries by defining the constraints between those dependencies. So basically, the configuration is very self-explanatory, as you can read the configuration object. For example, a source or project tagged with a scope API can only depend on libraries with the tags scope API and scope shared. That's what you see here. So now if we would import an API library into the CMS application, as we saw before in the dependency graph, running the linter would fail and would block the further execution of, for example, automated builds. And the warning output that we get is pretty clear. A project tagged with scope CMS can only depend on projects tagged with scope shared or scope CMS. So scopes only represent one dimension of tagging. We could easily add more tags. For example, dividing our libraries into different types is one great example of an extra dimension. So adding a different type is easy, or different tag type, but the general, adding a different type is easy, but the general recommendation is to keep it simple. You always need to keep it comprehensible. It should be clearly documented so that each member of your organization understands that division. And NX basically recommends the following type libraries: feature libraries, UI libraries, data access libraries, and util libraries. And feature libraries are typically the libraries that implement smart UI features that fetch, process, and visualize data. Like, for example, a very specific business feature or a single page on your website or an application. Feature libraries can import its own type and all other types of libraries, but only from an allowed scope if those are defined. So the thing I talked about, scope, API, CMS, shared. UI libraries, they typically contain DOM components that represent the visual presentation layer. They do not provide features, but they are mainly used in composing into features. So UI libraries can only import other UI libraries and util libraries. Allowing them to import feature libraries or even data access libraries would too tightly couple them to a specific library, and that would probably not keep them dumb. Then data access libraries contain functions that interact with other services, like, for example, a backend or a database. This is also where you would typically put state management solutions. You would categorize them in data access libraries. Data access libraries can only depend on other data access libraries or on util libraries for the same reasons as with UI libraries, because we want to avoid coupling data access libraries to specific features or to UI implementations. Util libraries, the last type that NX recommends, are basically just helper libraries that contain very low-level utilities that can be used by any other library, like, for example, sorting or running an automated process. And they're typically pure functions, because they are typically also separated from state or from specific implementations. So util libraries can only import other util libraries, but in general, that already gives us plenty of options to keep control of a potential wild grow of different types of libraries, and it will keep our architecture clean. A very specific remark that I want to make is that you should not let a library depend on itself via the aliased imports that TypeScript provides, because that will probably create a circular dependency and it will make NX tooling less efficient. But I will show you that in the examples. The good thing to know is that the same ESLint rule that we introduced for the enforcing of module boundaries will also warn you about circular dependencies. So the next big helper functionality that NX provides is caching. And as I mentioned during the introduction, caching does not always need to be one of the most difficult concepts in computing. And in the case of NX workspaces, I found it to be very refreshing and even mind-blowing if you notice the gain that it generates in running even the most daily tasks while developing, but also in the automated software release processes. So the gain from caching alone even scales and becomes bigger together with the growth of your data, of your code base. And to now directly quote the documentation of NX, they have a very good line on that. They say that NX becomes more valuable as you scale because it will solve problems that are frustrating for small teams, but they are truly paralyzing large teams. It will just completely block them. So let's take a look at caching. So in general, it's just costly to rebuild and retest the same code over and over again. So why would we run the whole process again if we can just reuse the generated output from a previous run? And this is made possible by caching the output of that previous run. So what do we cache? We cache the output from the terminal, but also the files that are generated as the result of that specific action. So if we then know in which case that we should do a fresh run and update the cache, we could use the same but opposite condition, of course, to avoid the run completely, but use the cached output of the previous run. The previously saved output is sent to the terminal and the exact same files are written to the file system. And of course, NX will annotate the output. It will add something extra just to show you that instead of running the command, it just pulled out the artifact from the cache. So how does NX know when to ignore a cache result? So how does it know when it should rerun the command and save the output of the rerun as the new cache result? There are 3 different sources of input for defining if a cacheable operation has changed. And it also defines when we need to regenerate the cache. So the first input is based on the builder and its arguments. So only the actual command and arguments that are executed in the end are taken into consideration. Like, for example, the --prod argument is basically just an alias for configuration equals production. So if you would run npx nx build admin prod, it would also try to fetch the cache for npx nx build admin -- configuration equals production. So it's considered the same action. The second input is based on the state of the environment. So, for example, a cache generated with Node version 12.16.1 should not be reused on a machine that has Node version 14 installed. And the same applies, for example, the operating system or a defined set of environment variables. This is all configurable, so this is not the default configuration. I just want to show that you can use environment variables as an input for the the function that determines if we need to recache something. Then, of course, the biggest form of input is the actual code, but also its implicit dependencies. So if any part of the code of a library or application that changes, then we have to trigger a new run and execute a command. So as I mentioned, also implicit dependencies. If, for example, the package JSON changes, we should ignore the cache and do a fresh run. And then NX takes all those inputs and it uses it as a base for a hash function that identifies the cacheable object, and that cacheable object will include the output generated in the terminal and also the files generated by the process. And then these cached objects can be stored in a local cache on the workstation of the developer, or even online in a remote cache on a server. Now, let's take a closer look on the local versus remote caching. So with local caching, the caching objects are stored locally in the project, but the configuration, the location is configurable. And by default, we can find the cache in the node modules folder. By default, the cache objects are valid for 1 week, but you can simply remove them by clearing the folder in your node modules. And if you really want to skip the cache for any reason, like for example, you want to benchmark how fast a command is running, or you want to really test something with a fresh, with a clean sheet, then you can just provide the skip NX cache option. With remote caching, the cache objects are stored on a remote server. So in that case, the cache can not only be reused by yourself, but also by other team members and even other processes, like for example, your GitHub actions that do your continuous integration and deployment. So if a cache object was generated by somebody else using the same remote cache, that cache object will be copied into the local cache. So the next time it can be used, it will not be retrieved from the network, but directly from the local cache on the other developer's machine. And then when I was preparing the presentation, I thought about something. I didn't test this out, so this is theory, but in your enterprise, it could be that you might not need really remote caching, because theoretically you could also use a shared drive on the network of your company to enable the cache. So yeah, that would require you to set a local caching configuration, but it would imply that you're using a distributed and remote cache, because all devs in the enterprise can access the cache. And as I said, this is only theory. I haven't tested it out yet, but it does make some sense from a networking perspective. Now, let's take a more structured look into this process. So developer A executes the command to build the production version of the admin application. Then the NX workspace will calculate the hash identifier of this run based on all the relevant inputs that I described before. It will first check the local cache for the existence of a cached object, and if it does not exist, NX will check the remote cache for its existence. If that does not exist as well, NX will execute the command. The result of the command is, of course, printed out in the terminal of the process or the developer that is executing this command. And if applicable, the generated files are written to the file system. Meanwhile, NX is already adding the files and the output identified by the previously generated hash to the local cache, and it also does the same for the remote cache. So it pushes the artifact and the output to your local cache and also to the remote cache. So basically, the developer A running a specific task for the first time on a specific version of the code will pave the way for the next developer, or for a subsequent run, the next run triggered by himself. Now, somewhere else on the other side of the world, developer B, which is a member of your globally distributed team, pulls in the code. And he also needs the same production build of the admin application for whatever reason. And just as before, NX will calculate the hash identifier of this run based on all the relevant inputs, and will first check the local cache for the existence of the cached object. So for the sake of the example, we assumed that the inputs for defining the hash, for calculating the hash, is exactly the same. So it does not exist in the local cache of developer B. So it checks the remote version, the remote cache. It exists because developer A already generated the output. So it was pushed on the remote cache. And the cached object from the remote cache is returned to the local cache and to the workspace. The result of the command is printed out in the terminal, and if applicable, again, the generated files are written to the file system of developer B. And meanwhile, of course, the remote object is also saved to the local cache. Now, if developer B would call the same command again with the same conditions as before, NX would only have to check the local cache to rerun the output and the generated files. It does not need to query the remote cache anymore. So imagine if the production build would normally take 5 minutes to run, developer A had to go through that time and wait. But developer B gets the results almost instantly because he only needs to wait on the calculation of the hash, which is basically, you can ignore that, it's not significant. And also the network time that he needs to retrieve the cache object. So 5 minutes basically becomes 2 seconds, which is amazing. So what we see here is the configuration object for the task runner. And this is also part of the NX JSON file, which we will discuss a bit more in depth during the examples. And in this case, we have configured the runner to be using the remote NX Cloud runner. NX Cloud is a platform as a service that Narwhal provides, and it's basically just a very big interface to the remote cache. And they also have a free plan to get you started and test out the service. So you can try it out for free. But if you would leave out the runner, it would just default to the local cache configuration. There are also other options available, like, for example, you could use a community plugin that will allow you to use, for example, AWS as caching store. So an S3 bucket, for example. And then you could save your cache objects on whatever remote file system that you would like to use if you are just willing to create a similar plugin. So the first common configuration, independent of whether you're using remote or local cache, is the cacheable operations. And here we decide which tasks that should be treated in the cache. So basically we can add any other operation here, as long as we can define it as a target on a library or a project, like we can see here, build or test. If you have, for example, an Angular universal application, you could also add pre-render here to the cacheable operations. Then the second common configuration is that of the runtime cache inputs, like, for example, the node version that we discussed, or any other important environment variable that you want to consider in the hashing function. And then finally, finally, the cache directory can also be configured. And as we see here, the location of the cache directory is configured to the NX cache folder on the shared S drive. So this is, again, theory. I have not tested it, but from a networking perspective, that could make sense. So what we see here is a practical example of the increase in performance that enabling caching for a specific task gave us in a project. So by default, the pre-rendering operation is not cached. And just by adding pre-render to the cacheable operations, we optimize the rerun of a pre-rendered task on the same conditions from 4 minutes to around 45 seconds. So if we run this task regularly, for example, on our GitHub actions that enable continuous deployment, we have to pay for only 1 minute instead of 4 for each run. And that might not seem very much on an atomic level, but the benefit grows as you do more deploys, as your code base grows and your project grows, of course. So if we now combine caching and affected, we get the best of both worlds, of course. because running affected alone will give us the benefit of having a smaller list of tests to run, but running it twice will just test that list twice. And when we run with caching alone, the list of projects to test is very big. But when we run it twice, it will effectively only run the tests once. Now, if we combine both, it will make the list to test very small, but running it twice will effectively only test that small list once. So that's pretty amazing, and it's the benefit that that brings is huge. So that was a very big chunk of theory, and I hope it was all clear. If you have questions, please write them down for the Q&A session at the end. And before we dive into the code examples, I suggest that we take a small break, 3 to 5 minutes. Let's say that we meet again at, it's now almost 8 local time. I don't know what time it is at your side of the world, but let's take till 5 after the hour. So 5 past 8 to meet again, and I will set up my testing environment. So see you back in 5 minutes. All right, I'm going to start with the practical demo. So the practical demo will basically show most of the theoretical stuff that we have seen during the presentation. But if after the presentation something is still unclear, as I said before, please write down your questions and we will take them after the session. So we will start with generating an NX workspace. So generating a NX workspace is very simple. You don't need to install anything. Well, basically, you don't need to explicitly install anything, but you can just run npx create NX workspace. And if you run this command, npx will download the library and it will run and it will ask you for your workspace name. So this is the name basically of your organization. If you work in a large enterprise, you would probably take the name of the enterprise or a division of that enterprise. So let's for now just take as an example Juvo. And then NX asks you for which technologies or which frameworks that you want to generate the project. And as you can see, there are quite a few technologies that come by default, like React, Angular, but also in combination. For example, a React with Express or an Angular with a Nest application. Just keep in mind that if you choose one now, it doesn't necessarily mean that you cannot use anything else anymore, because that's one of the powers of NX. You can add other capabilities at any point in time later. So when we, for example, take Angular Nest, we should give the application name for the application that will be generated. Let's take example here. And then we can choose our default CSS framework. And then NX asks us if we want to use NX Cloud. And they say it's free, it doesn't require registration. That's true. They give you a free testing account to just get used to how it works and get to know the benefits of it. Now, if you already have an existing application set up, for example, using the Angular CLI, there are two options that you can use to just add NX or parts of NX to your existing workspace. One of them is npx make Angular CLI faster. And what this command will do, if you run it inside your current workspace, it will simply decorate the Angular CLI with the caching options. But if you would already have an Angular CLI workspace, you could just do ng-add/workspace, and then your Angular CLI project will transform into a NX workspace. And it will do that by just running some schematics, migrations, and it basically transforms your workspace. There are also other migration guides available for other frameworks, like Create React App from Facebook, but we will use Angular in combination with Nest.js today for the examples. And to get a good overview of which commands are available, you can just do npx NX list, and it will fetch all the available and registered community plugins. Okay, I need to go into a directory, this example. And then you can see, for example, in the example library that I already set up, we have some plugins installed, but there are others available. And we even have community plugins available that we can install. And there are plenty of plugins already available. Like, for example, plugins supporting Firebase, supporting Vue, Svelte, Stencil, but even frameworks that are not built on JavaScript, like for example, Go or Spring Boot. So NX is not only capable of providing monorepo support for your JavaScript frameworks, but also for Dart, Java, .NET, and Go. So keep in mind that most of these plugins are external contributions, but from what I can see from the activity in the normal Slack and NX Slack and on GitHub, they are very supportive in providing information and help on how to get those libraries built. So, as I said, we will continue with Angular for now, because to be honest, I only have experience with Angular and JavaScript backend frameworks, like for example, Nest.js and Express. For some reason, I have not been tempted yet to try out React. Shame on me. But I already bootstrapped in the next workspace for the example, so let's check it out. And if you want to follow along, you can just clone this repository. I hope I made it public. It should be public. So you can use this, or you can use the HTTPS version. But normally, if you just go on GitHub to my profile, you should find the repository. So if we check out the basic setup of our repository, we see, of course, that we have apps, and apps are the application projects. And the main goal of application projects is basically just an entry point for our runnable projects. And the goal is to keep them lightweight. So the general recommendation is that we put most of the code and all the heavy lifting in libraries. And you can use the app as an app shell, but even that could be done in a library. So an app is just a very basic entry point for all the rest of your code. Then we have the libs, and libs are library projects which which can hold different kinds of libraries, like I mentioned in the presentation, feature, util, UI, and data access libraries. And then tools is a folder that we can use to put our scripts that act on a repository, like for example, custom executors or generators and schematics. Other supportive tools like optimization processes for pre-rendering, database scripts, stuff like that. Then we have the workspace.json or angular.json file. And in our case, it's an angular.json file. This is just a general configuration file that defines all our projects and their executors and the configurations that are linked to it. Then we have nx.json, and nx.json contains the NX specific configuration, like for example, extra meta information on your project, like the scope for NPM, implicit dependencies, and the task runner options. But it also contains extra information like the tags on a project level. And in this case, in a very bare minimum setup, it does not have any tags yet. Then the last main file that we should check is the tsconfig base configuration file. So that's the basic TS configuration, but here we also see the paths that create that enable nice imports using the aliases instead of doing .. and then going back down again into your library. One other file is the one that I mentioned, make your Angular CLI faster. And that's basically just a decoration of the ng command, making nx a wrapper around ng. And ng will also be an alias now for nx, by the way. So nx does everything that Angular CLI does, but with more options. For example, you could still use ng-g component to generate a component. That will still work. Now, for the sake of the example, I've already prepared some example libraries and applications. And if you want to go along, you can check out attack. 2-apps-libraries. And now, normally, if all is good, I will have some libraries and an application. So let me show you by running it. Serve npx nx serve API and npx nx serve CMS. So, so I am using WebStorm as my preferred editor, but many of you probably use VS Code. And it's good to know that Narwhal has, let me see, the command started. Yep. So Narwhal has developed a VS Code plugin that's called NX Console, and that will give you a very nice interface on top of the NX CLI commands that you can just use an interface in your VS Code to run all the commands instead of using the command line. WebStorm has some similar plugins available, also contributed by external contributors, but I have not myself been tempted yet to try them out. I've always been very comfortable with the terminal. So the application should have started. Let me open a browser. Hello. Here it is. So I have a very basic API running with an endpoint ping. If I call it, I will get back pong. And if I have, if I start load my CMS application, I will just see a very basic list of users, and I can check the details of those users. So as you could have seen, when I started both application, I used the same consistent syntax. I used npx nx serve CMS. And for the API, I used the same. I just did npx nx serve API. So even though they're backend projects and frontend projects, the syntax used is exactly the same, which is very nice. So, okay, this example setup has been configured using those tags. Let me see. So for this configuration, I've disabled the remote cache, so I'm only using local cache. But the projects all received their appropriate tagging. So for example, scope CMS for the CMS applications, scope API for the API application, but also for the specific API libraries. Same for the shared library and the same for the CMS libraries. What we also did was divide the projects into different types, like an application gets the type app and specific libraries get their type tag. For example, here, type feature. Now let me show you the dependency graph. npm run dep graph. So there will not be much to see here because the example is not very big. But as you can see from the dependency graph, we get a very nice view of the architecture of our monorepository. So NX can recognize that this was an implicit dependency and also annotates it with implicit. And for example, this one is a lazy loaded library, which we can see with the dotted arrow. And this kind of looks the same as the example that we saw in the presentation. Now, if I would make one change to, for example, let's start with CMS data access users. Go to libs, CMS data access users. And I would add a function Europe. Hello, very simple. Would run the dep graph again. Oh, check why that was not working. Oh, I need to do affected. So, affected step graph. If we select all, we see that by changing one thing in the CMS data access users library, that NX knows that if I change something here, I will also need to run the test for example, CMS feed users and CMS end-to-end. As I mentioned, this shared type user is used by all of our applications and libraries. So if I would make the change a little bit bigger, and I would undo this change, so shared type user, I would add location here, optional. I would run the deb graph again. We would see that now all of our projects are changed. So, oh. So NX knows that all our applications are touched by the change. So if I would now do npm run affected test, it will run the tests for all our applications and libraries. So we see all of them now and it starts running them and all tests are good, which is good. But if I would undo my change and do it again, it will say that there were no projects with tests to run because there was nothing affected. And we can see that from running the affected deb graph. And everything is just black. All right. What we can also do with this dependency graph is, if we want, we can focus on one specific library to see the impact that it could have in our architecture. We can also exclude it so that we only see, I'm going to select all again and exclude this one. So if we would remove the dependency of this type library, we would cut the dependency between the two applications. So making any change in a CMS related library would totally ignore the tests and the builds that we have for API library. Now, let's show something else. We mentioned that we have the scoping of the libraries and the applications with the scope CMS and type app. So we need to configure that in the ESLint. And we do that like this. We say that a project that has a scope CMS can only depend on libs with scope CMS and scope shared. So if we would go into, for example, the CMS application, and we would try to import the API feed users module, which is also just a module. So this one, let's say we want to import the user module. It will say, let's see. ESLint will complain saying that a project tagged with scope CMS can only depend on libs tagged with scope CMS or scope shared. And if you would run a lint now, so let's do npx run, no, npm run affected lint. It's running the lint for the CMS and the CMS end-to-end. And it should fail. Let's wait. Voila, it fails with what we mentioned before. And there's another error, but that's fixed in the third part of the example. So now it just warns us. Now it really breaks the linting process, but we could also warn it, but that's not recommended. All right. Let's reset. Oh. Okay. Now, just to show you the speeding up of the caching, I will go first inside .cache.nx. I'll clear it all. So if I would now run build, well, wait, I'm gonna time it. So npx So running the build for the CMS will now take, let's say, around 15 seconds or something. It's even more. 20. Some people say that Angular is slow. I don't think so. But, 26 seconds. If I would run it again now, normally it should leverage the cache and be instant. So now it's downloading Gnomon, but bam, it's instant. So running it again, we go from 26 seconds to 100 or almost 207 seconds. Locally on my machine, of course. If you would need to go to the remote cache first, it will probably be 2 or 3 seconds, but still amazingly fast. So now I will quickly show you with an Nextcloud enabled, and therefore we can check out another tag. Just a second. Git checkout. Voila. And now normally we have yes, Nextcloud enabled. And now if we run again npm run build, it will build the default application, which is the production build of the CMS. Probably again 26 seconds. 24 seconds. Voila. So we also get output now that Nextcloud has stored some meta information about our run. So if you visit NX app, we can immediately see some nice data about the run of our action. And this is pretty nice because if you want to share the output of what you have run locally, you don't need to copy it to another developer in Slack and say, here's the output of the command. You can just copy paste the run, and then the other developer can check all the information that you saw in your terminal with all the configuration. If there was already a cache. So if I would run it now again, it will be cached. We get another run, but the other run will say that we did a local cache hit because it's on my machine. So if anybody would check out the repository now on this machine and run the same configuration that I did, you would probably do a remote cache hit. All right. And that was it for the examples. Let me quickly start presenting again. Just a second. Almost there. Where's my Zoom? Here, share screen. Share. So normally now you should see the slides again. If that's not the case, please let me know, Nick or somebody else. So let's go to a conclusion. So just to put it shortly now, NX, it allows us to build, test, and scale our applications at any scale using any modern GS framework. So you could use Vue, Svelte, React, Angular. They are supported out of the box. Not for Vue or Svelte, but definitely Angular and React. But as also mentioned, it's not only JavaScript frameworks. There are tools for plugins available for Go, for example, for Spring Boot and others. And we can use caching to minimize the time our processing needs to execute. The examples are perhaps not so mind-blowing, but if you are developing on an NX workspace for 1 or 2 years, you will definitely see an immediate and very big impact. We also saw that using smart techniques, we enable smart execution of our tasks, and we only run if needed. Then the dependency graph also allows us to have a clear overview of our architecture, and we can also control the boundaries between the relations between our apps and our libraries. Everything that I told you today is also mentioned and explained in another but very similar way on the official documentation of NX. So you can check out nx.dev and nx.app. Also be sure to check out the GitHub organization of Narwhal, because there are a lot of example repositories for different technologies, and their YouTube channel is pure gold because they have free courses and free workshops that you can follow and listen to get you started on using the NX workspaces. So thank you very much for your attention. If you have questions, feel free to ask them now. But if you want, you can always contact me on Twitter or via my email directly. So thank you very much, and I hope to see some questions. Okay, I already see some questions here. So, is there a benefit on using a monorepo structure to combine multiple applications with different business domains design, or would it create more overhead because the life cycles would be too different? I think that's more of a decision that you should take on your company level or organization level, because you could have everything inside one monorepo, but still have it completely segregated from each other. So as long as you do not start importing libraries or types or whatever from another application, it will completely be disconnected from each other. So you can have separate processes for each part of your organization. So overhead, well, there's always overhead if you in each approach that you take. If you have single application repositories, it will create another overhead than having the overhead of a monorepo. So yeah, it's weighing the benefits against the drawbacks. So yeah. Another question was, can you use a remote cache if you have made code changes? Yes, you can use a remote cache. Wait, it always compares against the base master. Can you use remote cache? Well, the cache is calculated based on the changes of your input. So if it would generate the same hash, then yes, you can use a remote cache. Yeah. So it all depends on the environment variables that you have configured, or for example, the platform, Windows versus Mac, for example. But that all depends on your configuration. So another question is, do you still sometimes consider using a traditional Angular repository, or do you go for NX by default? I go for NX by default. It's as simple as that. Even for local development, the caching is amazing. Not having to wait 5 minutes or 10 minutes for a build to end. It's just being instant. It's insane. Same for the test, same for linting. Yeah, so even as a single developer on one stupid project, you could already benefit from NX. Yeah. Those were the 3 questions. I hope my answer was somewhat satisfying. If not, feel free to post a follow-up question or some remarks. I don't see any questions arising anymore. So Dimitri or Anne,
Okay.
You have the mic.
Thanks a lot, Sam. Very interesting workshop. I've learned a lot of new things, but I'm more on the Java side, so I will definitely give it a try for using it with Spring Boot. But a lot of our colleagues will give it a try with Angular applications. So thanks a lot, and especially for the demo also.
Yeah, I know the demo was perhaps a bit basic, but yeah, the true benefits of using the cache and the dependency graph, it immediately becomes clear as soon as you start using it. There are already some superb documentation and articles available on the internet that you can find with these that will give you more options, that will explain it even more in depth. So yeah, just Google it and you will find it.
Okay, thanks. This was our last technical workshop before the summer holidays in Belgium. We have a next webinar planned in June. We have already had two webinars about making our organization a data-driven company. The first one was to give you examples of how data can help you in your company. The second one was more about architecture. The last one is a roadmap for becoming a data-driven company. We will give you some hands-on examples of how you can start making your company data-driven, what are the pitfalls, and how can you measure if you are having a successful data-driven company or not. So don't forget to subscribe yourself. Just go to webinar.juvo.be and hope to see you all very soon in the next webinar. Thanks a lot and have a nice evening.
Bye.